Good morning, student. Today we are going to learn about quadratic equations. So the three types of formulas is here. So already we know the quadratic equation or polynomial equation. So the first one, zeros of a quadratic polynomial. Zeros of a quadratic polynomial. Zeros of a quadratic polynomial. Let p of x be a polynomial. So what is polynomial? The term of a numbers. In example, x square plus 5x plus 2 is a polynomial. In the higher value, in whatever is correct. So x cube plus x square minus 2x plus 2 equal to 0. This is also polynomial. So this x plus 2 also polynomial. So already in 9th standard we learned the different type of polynomials. So now we see the zeros of a quadratic polynomial. So quadratic meaning the always the power value is x square only. X square only. So let p of x be a polynomial. X equal to a is called 0. Of p of x is p of a equal to 0. So in this type of conditions we see the examples only, we get a better understand. Okay, so the example p of x equal to x square minus 2x minus 8. So this x value, this is we consider x equal to 4 and x equal to minus 2. So if we substitute the x value, this polynomial equation, see here I substituted here x value 4, x value 4, x value 4 minus 8. So 16 minus 8 minus 8 minus 16. So we get a answer is 0. So p of a equal to 0. So here also in example also 0. So like this the second one x equal to minus 2. So if we substitute minus 2 here, we get the answer is 0. So therefore minus 2 and 4 are zeros of the polynomial p of x, x square minus 2x minus 8. The second one, roots of a quadratic equation. Let roots. So this one roots of a quadratic equation. So here roots, let ax square plus bx plus c equal to 0 is a basic equation, be a quadratic equation. The value of x such that the expression ax square plus bx plus c becomes 0. So what displays fully 0 are called roots of the quadratic equation. Roots of the quadratic equation, ax square plus bx plus c equal to 0. So this is a quadratic equation formula, roots of a quadratic equations. So x equal to minus b plus or minus root of b square minus 4ac divided by 2a. The third one, formation of a quadratic equation. Formation of a quadratic equation. If alpha and beta are roots of a quadratic equation, ax square plus bx plus c equal to 0, then this is a quadratic equation. This is a quadratic equation. So this is a formation of a formula, quadratic equation, x square minus sum of roots plus into x plus product of roots equal to 0. So x square minus alpha x plus beta equal to 0. This alpha noted by sum of roots. This beta noted by product of roots. So here alpha plus beta. This is alpha beta. This place alpha plus beta x. This place comes alpha beta. Okay. So alpha plus beta x plus alpha beta x. So the sum of roots alpha plus beta. Product of roots alpha beta. Okay. So the first question, exercise 3.9. Determine the quadratic equations whose sum and product of roots are. So the question having sum of roots and product of roots values. We should find the quadratic equation. So take the formation of quadratic equation formula and substitute the sum of roots place and product of the roots place. The first value minus 9 is sum of roots. The 20 is product of roots. So the formation of quadratic equation formula x square minus sum of roots x plus product of roots x. So sum of root of x value minus 9, product of root of x product of roots value is 20 equal to 0. So x square minus into minus plus 9x plus 20 equal to 0. So this is our correct equation. So the subdivision 2. So the first one sum of roots value, the second one product of roots value. Write this formula and substitute the values. Sum of roots value 5 by 3, product of the roots value 4. So this place having divided by 3. If we multiply in both sides, this place become 3x square minus 5x, 3 4s are 12. Then again we write in denominator part 3. So now this 3 goes to right hand side, 3 into 0, 3 into 0, 3 into 0 become 0. So finally we get 3x square minus 5x plus 12 equal to 0. So the third question, minus 3 by 2 minus 1. So the same sum, formation of quadratic equation, and x square sum of root x plus product of roots equal to 0. Substitute the sum of root value and product of the root value. Then minus into minus plus 3 by 2x plus into minus minus 1. Here also the divided by 2 multiply in both sides. Both sides meaning in left hand side only, in equal left hand side only. So 2x square plus 3x minus 2 divided by, again we write this 2. This 2 we can multiply in right side, 2 into 0, 0. So 2x square plus 3x minus 2 equal to 0. So the fourth question, minus 2 minus a whole square, a plus 5 whole square, formation of quadratic equation x square minus sum of root x plus product of roots equal to 0, x square minus sum of root x value minus 2a whole square x plus product of roots value a plus 5 whole square equal to 0. So x square minus into minus plus 2 minus a whole square x plus a plus 5 whole square equal to 0. Okay, this is very important and easy sums also. Okay, so the second question, find the sum and product. So this question given a equation, in first sum, given the sum and product of roots, we find the equation. The second sum, the question having the equation, we find the sum and product. So first of all, in formula page, we know the ax square plus bx plus c formula, okay, equal to 0. This is a quadratic equation formula. So comparing the given equation, this x square, this x value. So a value 1, this a and here 1, a value 1, x square value. Comparing x value, so b value 3, so c value minus 28, We know the formulas, alpha plus beta equal to minus b by a, product of alpha beta equal to c by a. So alpha plus beta minus b by a, product of roots alpha beta equal to c by a. So minus 3 by 1 equal to minus 3, c by a equal to minus 28 by 1 equal to minus 28. So the second one, so this is our answer, sum and product. So sum and product, minus 3 and minus 28. The second one, x square plus 3x equal to 0. So here constant part is not given. So we take the C value is 0. So comparing this equation, so A value 1. If it is not here any value, we consider 1. Okay, so this is polynomial equation rules. So A value 1, B value 3, C value 0. So we know this formula, alpha plus beta minus B by A, alpha beta equal to C by A. So this is sum and product. So minus 3 by 1 equal to minus 3, because denominator 1 is, we write minus 3 only. So here 0. So this is sum and product value. The third question, 3 plus 1 by A equal to 3 by A square. So here not given the formula method, the equation method, we should simplify the equation method. So this A multiply in left hand side, this left hand side. So 3 into A, 3A plus 1 divided by A, 10 by A square. So in equal to, in both sides, we can cancel the denominator part and the numerator part. This is max rule. Okay, so this 1A cancel. So here another 1A is here, this place 1. A into 3A plus 1. See here 3A plus 1 equal to 1 into 10, 10. So 3A square, A into 3A, 3A square, 3 into A, 1 into A equal to 10. This 10 comes to left hand side, we get a equation 3A square plus 3A minus 10. 3A square 3 plus A minus 10 equal to 0 is a equation. Comparing AX square plus BX plus C equal to 0 formula. Hereafter normal method only. So A equal to 3, B equal to 1, C equal to minus 10. So alpha plus beta minus B by A value, B value 1, but formula minus, so minus 1 by 3. Alpha beta C by A, C value minus 10 by 3. Okay, the fourth question. So here variable A, here variable Y, but our formula always variable in X only. So comparing this equation, the given equation, A value 3, B value minus 1, C equal to minus 4, sum of equation value alpha plus beta minus B by A formula, substitute this value, we get 1 by 3. This is formula minus this B value minus 1. So minus into minus plus 1 by 3. Product alpha beta equal to C by A minus 4 by 3. Okay. Thank you, student. So you can try to solve the example sums also. Okay, in your classwork note only, not rough note. Thank you, student.